This video is about reflection. We are getting into geometric optics, and this is a good starting point. The idea with geometric optics is that we are treating light as rays, and if you don't remember from geometry, whatever grade that is that you take that, a ray is something that has a starting point and then goes on forever in one direction. So that's how we're treating light. Reflection is particularly nice because it leads to the simplest physics equation that we come across in, I think, all of physics. I don't think it could get much simpler. If we have a surface like this, and this is a mirrored surface, then we can have a ray of light hit that surface. The incoming ray, this is called an incident ray, and it strikes the surface. Now when we do optics, what we need is to measure everything relative to the normal. The normal is just a line that is perpendicular to the surface, or perpendicular to the interface, I suppose. Call this a normal vector. And in math, normal doesn't mean not unusual, it just means perpendicular. So that normal line is perpendicular to the surface. I'm going to reflect off of this surface, which means bounce off of, and I'm going to do it in this way. This is going to be my reflected ray. And I have a simple relation. The equation that I have that relates these is right here. I have an incident angle, and I'm measuring that relative to the normal. And over here, I have a reflected angle, and my equation looks like this. My angle of incidence is equal to my angle of reflection. That's actually the entire equation. There are questions like, sure, I get this. How do I make this harder? Because there's got to be a way that this gets harder, right? And there is. I mean, you can do this. You can trace this out more. So maybe I've got a mirrored surface that looks like this. And a second one that meets it. Like this. And now I've got an incident ray that comes in here. And then it becomes a question of what happens to this. So I'm going to draw my normal vector. And here's my incident angle. And this thing is going to reflect off. Like this. There's my refracted angle. Now it is true that if my incident angle equals my refracted angle, then this angle over here is also equal to this angle over here. But we're going to measure everything else in optics off of this normal, so we may as well get used to it now. So now I'm striking here. I've got a new normal vector. That looks like this. I've got an incident ray here, an incident angle here, and that's going to reflect. Something like that. So then that one strikes my surface here, a new normal, a new reflected ray, And that'll be something like this, because these two angles have to line up. Got a new normal again, so I can start to make these problems considerably longer. A new normal again, so a new reflection again, and I have escaped this thing. If I know an angle here, then I could potentially work backwards and find like all the different angles by adding them together, subtracting from 90, that kind of a thing. But if that's my initial ray, this would be like my final reflected ray when the whole thing's done. That's how I make a problem like this harder. It is convoluted and pretty cumbersome. Not conceptually difficult. I just repeated the same process over and over again. If you were to encounter a question like this, it is most likely that it would be a multiple choice type question, and you wouldn't necessarily have to go through 4 steps like this, 4 reflections like this. It would probably be limited to 2-ish, but now you know how to do it anyway.